So what do we do when we have an r, a radius that is negative, right? When r is less than 0. Well, it is possible for r to be negative. I know that sounds counterintuitive because radius is a matter of distance. But when this happens, instead of the point being at the terminal side of theta, it's the ray from the pole extending in the opposite direction. So if I wanted to plot negative 2 pi over 6, I would go to 2 pi over 6, and then I would reflect it across the x-axis. So no, I wouldn't reflect it across the x-axis. I reflect it, go the opposite direction of the ray. If I wanted to plot the point negative 3 square root of 2 over pi over 4, I would go to negative 3 square root of 2. I think that's a little more than 2. Square root of 18? Maybe. Okay, so we're going to go here. Let's just say that this is 3 square root of 2. How about that? And we go up to pi over 4, just let me write about here. So this is a point 3 square root of 2 pi over 4, but that's not what I want to plot. I want to plot this point. So what I'm going to have to do is extend in the opposite direction in order to get to negative 3 square root of 2 pi over 4. So let's try graphing one of these. So if I want to plot negative 3, negative pi over 3, I go to positive 3, I go to negative pi over 3, and then I go in the opposite direction. So this would be the point negative 3, negative pi over 3. Remember, though, it could have another representation, and that would be positive 3, right? 2 pi over 3. So why don't we go ahead and practice finding multiple polar coordinates given a particular point P. So let's consider point P with polar coordinates 3 pi over 6. This is A right here. Because pi over 6, 13 pi over 6, like in B, and negative 11 pi over 6, like in C, all of the same terminal side, this point P can be also located using these three different angles. So what's happening here? Well, if I take pi over 6 plus 2 pi, I get to 13 pi over 6, right? I go one full extra revolution around the unit circle. If I take pi over 6 and I subtract a negative 2 pi, right? Where's that? Oh, that's example C. That's like I'm going 2 pi in the opposite direction. So by either adding one positive revolution around the unit circle or subtracting one, we get right back to the point where we started, right? That's what we know about unit circles. When it comes to a point representing it with a negative polar coordinate, what we're going to do is we're going to add pi, right, because the distance is straight line pi, and then we're going to switch the sign negative. So we add pi and make our negative. Another way to do that would be to subtract pi and make our negative as well, because that will be the opposite direction, 180 degrees. If you turn it 180 degrees, you're walking the other way. So you are going to see a problem like this, hint, hint, wink, wink, on the exam, possibly on the chapter 8 quiz, hint, hint, wink, wink. And what I want to have you do is find the polar coordinates of a given point where we've restricted theta. So let's plot point P. So I have 2 pi over 3, so I go to a radius 2, then I go to pi over 3, and I need to find two more representations of this point. So if r is positive and my theta is between 2 pi and 4 pi, what I'm going to do is I'm going to add 2 pi. So I'm going to go all the way around the unit circle one more time. So I'm going to take pi over 3 plus 2 pi. Well, that's pi over 3 plus 6 pi over 3. So I get 7 pi over 3 is my new theta. So I would be at the point when x is 2, theta is 7 pi over 3. Next, I have r is greater than, sorry, this is supposed to be r is less than 0. Next, I have r is less than 0, and theta is between 0 and 2 pi. So I'm going to want to represent this with a negative. I'm going to have to make r negative. So let's be negative 2. And then what I want to do is I want to add or subtract pi. So I'm going to go ahead and add pi. Because what that's going to do is that's going to cause me to go all the way over here at a positive 2 pi over 3 plus pi. Well, that's going to be 4 pi over 3. But then I flip it, right? So I would be at negative 2, 4 pi over 3. So I can also represent this point by negative 2, 4 pi over 3. Last, I want my radius to be positive. Cool. And I want to switch colors because why not? And I want my theta to be between negative 2 pi and 0. So what we're going to do is we're going to go ahead and subtract 2 pi. So I'm going to go around the unit circle in the clockwise direction one time. That's going to get me pi over 3 minus 2 pi, which is pi over 3 minus 6 pi. So I'd get negative 5 pi over 3. So all of these polar coordinates represent the same point. And this is unique, right? In rectangular coordinate system, each point is only represented by one possible xy combination. In the polar coordinate system, we can have multiple, if not infinite, representations of a point. We can just keep adding and adding 2 pi over and over and over again. So here is a way, kind of a summary, you either, for k is any integer, so k can be positive or negative, right? You add multiples of 2 pi or subtract multiples of 2 pi, and you add pi.